Yes, in today's class, we are going to see about how we are going to predict the data from the different apps. Actually, last time we have learned how to do the classification, how to do the regression learner, and of course, you would have been seeing about your deep learning neural network, which is very easily available in a form of app. Now we are going to see with those apps, you would have learned how to use the different algorithms and you know how to get the data inside. Now we are going to see how you are going to evaluate it. Actually, when you talk about this neural network training and all those things, the very basic is that you have to understand that you have a data. Okay, for example, if you have 100 data, it means that 1 to 100 you have a data. It may be a single column data or a vector data, row by column, whatever it may be. See, now if you apply with an algorithm, any machine learning algorithm, what this algorithm will do is that it will take 50% or it has been defined by you. 50 of data, 50 data are being taken for training. Okay, it trains. Okay, it takes the training. It understands how the data behaves. Then once the training is over, then the testing will be done. Of course, the testing is that, it will test by the remaining 25 data. The available data will be 100 and remaining 25 data, it will apply the same equations, what it has been obtained here after the training. Here you'll have some equations, prediction equation or classification equation, whatever the equation may be, that the equation will be tested. And then once the results are at the optimum level, okay, you can able to see this, the equation will be once again tuned. This is how it goes. And this is what the training happens. This is what the iteration happens. Okay. And randomly these same 50 data will not be taken up. That is a very important thing. When you talk about iteration is that, many times it comes and it goes for the maximum of the accurate value, then it gives the final equation and states that how far your testing equation and how far your training equation are equal. And this is how you are able to do this in your all the prediction algorithms. Now, the remaining 25, you can apply it for validation. Okay. And validation is that, any sample which is not in the testing, it is not used in the training, as different 25 samples, you validate how far this equation works for the other data. Either it can be from the same, what I can say, data set, or you can take it from the outer data set. This is what a very big problem when you design something with the standard data sets. If you collect a data set, standard data sets, these data sets, will not give a sample of new data. And that is a very big problem for you. This is you have to understand here. The very important thing is that, when you have your 100 data, you have to separate it and validate the 25 data. If at all you are collecting your own data, for example, your data are being collected by yourself. Now it is your own data, or you can call it as created data. It is a created data. You collect it from the live environment or in the what I can say field, whatever it may be. Okay, you collect it. Then you go for example, if you have 100 data, and now you can make 100 data for testing. Okay, 100 data can be used for testing and training. Of course, you are going to define whether it is 55 or 70 or 80, whatever it may be. Now, if I want to go for validation, what I'll do, I'll take the same data collection from the field or area. Okay, the new data, the same pattern what I did. Now that I can apply for the validation. Then I can apply with the same equation. Now, my equation which has been obtained here is predicting exactly what I required. It's been validated. I think now if you don't understand what I'm trying to say, because if you are strong enough in what I can say applying these algorithms in the real-time environment, that will be very useful for you to make a very clear-cut idea that how to make this validation to be understandable. That is a very big question. And the thing is that you take library file, you work and you say that I did I work. It's not like that. See, actually, when you talk about machine learning, even a school children are also having the machine learning algorithm nowadays. And that is not the thing. How you are going to tune? There is more technical part of this where sigmoid functions are there. And you can have your validation, testing, tuning, and all those things are there. Okay, and of course, not that because I have seen many people in the college. I know R language, I know this language, I know that language. You take a sample and you run it and you put your own data. It's not at all accepted in research, because the same teacher who is sitting for your evaluation of your review papers also knows that these things are readily available. What is your part of your contribution in your research work? And that becomes a very big question. So that question has to be tuned lightly in the function, or slightly in your application, or slightly in the parameter, whatever it may be. This is how you can do it. That I'll discuss at the last moment, how to make this existing one, how to tune it, how to go ahead. That is what we are going to see here now. Now I'll just go back. I'll just take one data, then I'll do this learner app. And I think it will be more easy for you to understand it. First, I'll just go to one data set, which is being given by the student. I'll just download this data. So this is an Excel data. I'm just going to download this data. This data is readily available with all the parameters. I think you can able to see this very easily available data. I'm just going to edit it. Okay. See, the features are like this: V1, V2. And when you take this data, V1, V2, actually the candidate has given very clearly is that V1 and V2 are the two inputs, and H1, H2 are the output. You have multiple output. Okay, but we are going to consider only two, because it takes more time to run the code. Of course, you can do at your home, because it will take more time to run the data, and that becomes a very big problem for you. So I cannot able to complete it in time. That is not the reason I'm going to take only two data, and I'm going to use apps and how to test it. Okay. Now you have two data, is that V1, V2, H1, H2 are the outputs. Now I'll just go to this data, and then I'll just download it. I'll just copy it here so that it will be convenient for you and to understand these values. Now I'm just going to take this data one. I'm just copying it, and you can directly go there. The folder which I created is that PhD MATLAB app-based learning. I'm just going to paste it here. Now, when I'm just clearing all my work file, that is very important because you will be confused. It is very important, to clear here the work files. Now I'll go to the learner app. Okay, I'll go for regression learner. Okay. Now this is your regression learning app. Please, it takes some time. Now we are going to have your apps to be done for regression plot. Okay. Now we are going to take some plots, then we are going to see this, how it is going to perform. Please wait, it takes time to open. And now this is the regression. You know that in regression, there should be n number of, you can have n number of input variables. Still, you can have only one output. And that is a very basic thing you have to understand when you go for regression analysis. Now I'm going to take it from the file, not from the workspace. Now I'm going to take the file. I'm just going to open this. And entire data is not to be opened. Of course, we are not going to take entire data. I'm going to take only the few data. And this is a very important thing. You have to understand it. Now I'm just going to take H1. I'm just going to take only this much of data, not more data. I'm just going to take only 10 data. Why? Because you can understand the values. That is what the reason I'm just going to take it. Now I have taken these values. Now my H1 is my output. This is my input, V1 and V2. And you can see the range. I didn't take entire data. Okay. And now I'm just going to start the session. And you can see this, you have a lot of course, a new MATLAB is having a lot of, what I can say, algorithms. And you can see improved version 2022 and 2021 versions are very good. Of course, this is 21 version. An updated version is having a 21B is having a very good advanced machine learning algorithms. Now, this is the data, 10 data, original data. You can see this with the box plot, how the data are there. How the data are there. Now, it is based on record number. I want to compare with, I think you can able to see that B1 and response, H1 output. And I can make it as a marker. I can change it into V2 because I'm not interested in this. Because this is going to be a plot section. Now it is based on record number. What do you mean record number? 1, 2, 3 number. It is called serial number. 1, 2, 3 record number. According to the record number, how the Y is there and how your x-axis is there. Now I can change it to V1, V2, V3. Okay. Now this is the thing. You can see the data. Now I'm just going to make one app. I'll just make a linear regression. Okay, I think a linear regression will be nice. Okay, now I'll just going to use my training function. You know that these things are very common, and we would have done it in the previous class also. We are going to train it. Now I got that 0.50 validation. Okay, and this is what the predicted value, and this is what the obtained value. You can see it here. Okay, according to the record number, what is the prediction value? This is what the thing you are seeing here. And according to the V1, V2, how it is there, you are seeing here how the data are plotted. Of course, there's a very few data I have taken, and that is what the reason it is like this. And when you want to see this, what is the response? You can have the response. Now I'm going to take the predicted value. I'm just going to take the predicted value, and you are going to see the actual value. Then you are going to have the residuals. You can see the residuals of the values. And when you talk about the residual, you can see the true response. You can see this record number, and you can use your lines. You can use your box plots. And of course, you know, this is a very common thing you're trying to understand from this true response and your residuals. Okay. Now, when you want to have your minimum MSME, you can have it here plot. And train an optimization model. You have to optimize it. Of course, we are not going to do this optimization. Now, this is what the thing you get it here, you know, predicted as actuals. Okay, prediction model. Okay. And if at all, once again, I want to use advanced because we didn't teach that on the advanced level. You can see this advanced level. Okay, you can use your terms, you know, interactive, pure, productive, whatever it may be. And robust options, you can click it. If there is any robust options, okay, and you can apply it. Now I can train it once again. I can go for the one more training. Now it is training up. You can see this. This is the training, and this is the training function, and you can see the response. Okay, and now validation data are also here, and test data is also here. Okay, because we didn't select the model to see the predicted value and actual plot. Of course, other models is having these type of things, of course. When you go for stepwise function, you can have this. And now I'm going to run this. You can see the stepwise linear regression. Okay. And it is robust on. It's a one type of, what I can say, analysis. And you can see this prediction analysis. Now you can see a lot of things. Now, how to generate? Now, this is what the option I have given you. You know, you can test the data either here. You can test the data, and of course, you can even use your export the plot. You can have your export the plot because sometimes when you want to go for the papers, you can make it as a plot. Okay, you can make this as a plot, and you can get the values. Now this can be export a compact model or export model. Compact model is that, you know, you can make it with the difference is that, you know, current selected model is the history list of the workspace to make the prediction with the new data without the training data. Okay, export the compact without the training data. We don't have any training data. So you click this, Now the model name is train model T. Now you got this. Okay, you got this. Now this model will be, what is that model you are taking? It is for stepwise linear regression. If at all, if you click this and if you export this, then the name automatically will be changing into 1. Previously it was model 1. So only model. Here it has been taken as model 1. Okay, then and now I'm going to take this other one. Now I export this because all are completed. I'm just going to take model 2. Then I can export it. Now what happens? What happens at the background? See, when you see this training model 1, you can see the structs files. You can see the history of the data, how to predict the characteristics, and everything will be available here. And you can see the prediction function, and you can have the cells. What are the cells V1, V2 you had, and all those things you can get it. Now this is the prediction model. Okay, this is the prediction model. Now if I want to do it for a new data, see, when I press this first column, now I'll just make it 1. When I pressed it T, I got my prediction equation at the below as this function. This is the function. Now I can copy this. Okay, I can copy this. I can go for home. I can create one script file. Now I want to have a T file. Actually, what was my input? Input was only with V1 and V2. Now what I'll do, I'll just click here. I just click here. Okay, now I'm going to take randomly of V1, V2. Now I'm going to take at the bottom. Now I'm going to take, I think I have taken 10 values. You can take n number of values, no doubt in that. But still, I'll take only 10 values. I'm just going to export this 10 values. Okay, import data. Now the data is imported. Now this is my data 1. I can rename it as T. I can rename it as T. Okay, I can rename it as T now. Now, if I want to predict this particular T, this is what the T data, a new data. Now I'm going to predict with this equation because I have given the command. Now you can get it very easily. Now I'll just clear it. Okay, you can see this. This is the Y fit. This is the Y fit. When I evaluate it, this is the value for Y fit. Okay, Y fit value is that 0.00406, 0.00. This is the Y fit value. Now, once again, if I go to that, because I was selecting with this particular value, okay, 21 to 30. Actually, my H1 value is predicted a similar way, but there is a difference. Now, if I average it all the value, what is the percentage of accuracy? It is called 3.419. Now, what is the difference of your accuracy, prediction accuracy? I'll just go to the calculator. I'm just practically teaching about it. Okay. Now, your average value is 0. And actually, it has to give 0.3418, 0.3419. Okay. Now, minus of, actually, this is the answer. You're supposed to believe that this is the final answer because you have taken the data. Here, a lot of assumption is to be made here. Is that maybe this data would be wrong, or this data would have been correct. We don't know that. We are not aware about it. Obviously, we are not aware whether how far the quality of the data is there. You know, that is a very important thing that we have to feel it here. Is that you have to understand it there. Is that whether your data is correct or the predicted data is correct. Okay, now if I do it for some other data repeatedly, then you can understand what is the difference. Now, actually, I'm assuming that 0.3418 is the correct value. Now I'm going to apply. I'm just going to apply with the minus of what is that predicted value. What I got it here was your 0.046. Now I'm going to minus it. Now, if I minus it, I'll just go to the calculator. Minus 0.0406. Now, this is the value. The difference is 3.013. Now, divided by 0.0. Actually, what is that value? You expected is that, what is that Excel sheet value? Is that 0. 0 point, I think it is 21, 21, 0 point, I think 0.419, 419. I'll make it 0.419, 0.4, 0.3, actually 3419, okay, is equal to 8 minus 100. Now your prediction accuracy was able to get it about 91%. Okay, it was 91% of accuracy. What you have achieved is that 91% of the accuracy. Since your data are above your prediction value, don't say that it is beyond 100. The error percentage was only 8%. So accuracy is that 91. Your accuracy is about 91. This is how you have to calculate. Please don't try to understand that, when you get some value of prediction 3 and you get 4, don't say that it has already got the 3, it is completed. And so it's not like that. Actually, you want to get the 3. Of course, you got the 4. What is the error? Error is 1. And now error is 1. And that 1 divided by your 100% you consider as a 3, 1 by 3. So your percentage of error is 91. And this is how you have to predict it. Why we are giving such an option here? We may not be knowing that, a very important thing, we may not be knowing that what the value you are having is exact. And that is what the reason you have to collect a repeated data. First time you collect from many samples, then same samples you have to collect it. Okay, then if it gives the results, then no need to go for analytics engineering. Analytics needs engineers because you have to analyze why this data is different, why the difference is coming out, where the problem, where the prediction fails, where the data collection fails. If you are good at prediction, you become a good data analytics engineer. See, not that, you just put the code, oh, I didn't get it, oh, it's my data is wrong. No, it's not like that. You have to find out the error because every codes are available. Even this now, if I teach to any small people, they'll also understand. But the thing is, you have to understand why this data is giving this type of answer. Actually, you try to understand that prediction equation will not fail. Okay, but where the problem is, whether my input variable V1 is failed or V2 is failed or measurement errors happened at the output is failed. That you have to think and how to tune it. That comes your data analytics engineer. What I'm doing is just like a calculator job. It's not a very big thing. Okay, but people know things that end results. Oh, I didn't get 3, it's failed. No, it's not like that. It's not like that. You have to identify and you have to tune the work. That is very important. The prediction should be there. Next time, if you predict it, it should happen exactly what you predicted. And there may be a slight difference, not the entire difference. How to tune it? Of course, I think you could have seen this. Without going, there are 2 types of tuning can be done here. Now, neural network, I think if you remember about the neural net, what I taught, X and Y values will be the same, okay, and you will have an output for linear regression. When you go for neural network will try to tune your input values and it will try to match the output value. That is very important. Now, I'll check it out whether the same thing is happening for the next value. So I'm just going to take this, I'm going to delete it. Now I'm going to make a new set of values. Okay, now I'm going to take a new set of values. Now I'll go here and I'm just going to take at the bottom. Now I'll give a different value up to 10. Of course, you can give it for n number, no doubt. Now I'm just going to select it and now import data. Now the data is there in my workspace. Now I rename it. It is T. Okay, it is T. Now, if I run this code, I should get my predicted value. Okay, now my predicted value is once again 0.46. Of course, here one big problem is that if you click here, you may not be seeing these hidden values. You can see these hidden values. You may think that only 0.46. It's not like that. That is the beauty of the MATLAB. You can have n number. You can see this how many numbers are there. It keeps on going. Okay, but of course it is giving us a round-off value. When you change it, because these things are varied in the minute, well, now we'll go and see this value, how it is there in the value. Now I can go to the data. I have selected from 70, I supposed to believe 70 to 71. I think your V1, V2, 70, 71. 70 to 71 is that 1.15. This is the predicted value you're getting it. Okay. Now, how to increase this? Now, I'll go for the other algorithms because already we have gone for 3 methods, and those methods will have the what I can say, the naming model 1. Now I'll just make this 3 models. This is the name. Now I'll just make 1 model. Then I can see this copy. Now first one is the linear regression. I'm just going to make it this, because only the thing is changing here is 1. The other one is the 2. Okay, same data and different algorithm. I'm going to try it now. Now I'm just going to delete it now. I'm just going to delete this output because it will be overwriting the data on the same file and you may confuse. So I'm just going to delete this from the workspace. Now I'll just go ahead with my first linear regression model. I'll just go with my linear regression model. Model dot function train model dot model 1. Okay, I think model 1 is there. Model 2. Wait, I'll just check with the model 2. Model 1, 2. Oh, L is missing. L is missing. Okay. L is missing. Model 1. Model. Okay. This is what the reason. First time we got the error. Now I'll fit it now. First equation, y function, evaluate it. Now, if you go here, you can see the functions 633546. 35546. Okay, now I'll just go to the second one. Now this is my second equation. Even in my second equation, I'll just go type it here. Okay, all are giving the same results. That is what the confusion will come. So you can delete it. You can delete it. Now you can see the other one. Now my model is not able to get the same value. You can see this. You can see these values have changed. I think you're able to see this. Okay, same values are there. But what I'm trying to say is by the algorithm, this file has been changed. So I'm deleting it because if I keep the same file, you may think that it is not working. Now I'll just go remove it. Now once again, I'll go to my learner app. Once again, I can go to my learner app. Now I'll change my algorithm. Now I can change my some other method algorithm. Now here, I'm just going to go for neural network or any other supported vector machine based analysis. Now we'll see how it works. Now when I make this with linear SVM, I'll just make quadratic SVM. Now I'm going to train this. I'm going to train the same data. You can see this accuracy is being changed. Okay, now this is the value. Okay, this is the value. Somewhat it is reduced. Now I can go for some other one which is having the best value. I'll go for Gaussian model, Gaussian regression model. I can run with the same for the same data. I'll see how the data is accurate. Now you can see this, it is not accurate. Now I'll just go to this neural network trained layer. I'm just going to train it. Now it is a tailored neural network. Okay, it is a tailored neural network. Maybe this results are being obtained because you could have used more data. That is also one important thing you have to understand here. That is also very important. Now I'll just go here. We'll see how this neural network is going to do. Now I'm just going to take model 3. Okay, model 3. I'm just having the same data. No other change has been done for the input data. But the thing is that you can see it very clearly here. I'm just making model 3. prediction method. Now, if I run this code, now my fit has been changed entirely. Now, actually the value of this is that you can see here, what is the value showing here? 331, 33129. This is the prediction value. Actually, we have selected it for what I can say 70 to 71. And you can do the same thing for the other thing also. You know how to make the error to be calculated. Okay, now this is one thing. Now, this is for linear model of prediction. Now we'll go for once again with the other classifier algorithm. Okay, now this is a very important classifier algorithm. We are going to see some other new classifier algorithm. I'm just going to clear it because you have two input and you have two input and you have one output. Now we'll go for the other one. We'll go for classifier based algorithms. Now classifier based this is regression app. Now we'll jump onto the other app. Is that now we'll just go to this classification linear. It is called classification linear app. Now I'm going to do the same thing what I did it previously. Okay, nothing is going to make a very big difference. Okay, now I'm just going to take it from the file, not from the workspace. I'm just going to take the data. I'm just going to take the data. I'm just going to import the data. And now I'm just going to take V1 4 data, 10 values. Okay, 4 data. I'm just going to import the selection. Now you can see this responses. How many data I'm just going to take it. Okay, in the classifying app. Now whether I want to take H1 or whether I want to take H2, whatever it may be. Okay. Now I can start the session. Of course, it is the same thing what you did it there also. Nothing is going to have a very big change in the prediction values. Okay, and this is the original data. I should have taken more data because I don't have time. I didn't take it, but you can try it with your own data. Now I can apply here, and this is the training data. Now accuracy is about only 22%. Okay, and you can see this scatter plot. You can see the test data validation, and you can see this classification values: true class, true negative, true positive, and all those things here. And you can see this your positive predictive values and your false negative values, and the minimum classification. Okay, and now I can generate the similar way export data. Now model one, and the things are very common as we did it in the previous one. Same thing you can apply and you can get it out. So this is the model. This is the prediction model. You can apply the same t value. You can give the input and you can perform it. Of course, if at all you want to learn about the other apps, okay, we'll see in the next class. Of course, you need a lot of practice. Please try to practice it. And without the practice, if you ask questions, no, it is just like they're taking a theory note and you study something and you're trying to come out. No, that will not work out here. That is a very important thing. Okay, you have to practice and you have to understand where the problem is in the data, whether I have to tune the data, or you can have this reinforced learning. Of course, we'll see later on what is that reinforced learning also. Okay, now a very important thing is that how to tune the data. See, you have an Excel sheet. What is that you got as an input from this value? You can place it in your Excel sheet, and you can take a new data and you can apply it. And that is what they call it as hybrid algorithm. For example, if you have y1 or x1 and x2, y1 is your output. Or I can say that y is an output, x is the input, x1, x2 is your input, y is your output. Now you train something by giving x and y, x and x1 and x2. I think you can understand if I draw, you can able to understand something. Now you have x1, you have collected the data, and you have x2, you have collected the data. Now y1 is an output. as far as you're concerned, you have some values here, some values. For these values, you get some value 4, 5, 6, which is been collected from the field. Now, the same y is been predicted by this algorithm as 3 or 4 or 5. Now you keep this, okay, and you replace this y. Now you train both the thing. You see how the results are improved. Okay, and now when you see this, you can get a very beautiful idea is that now you are tuning this with linear regression and getting this value. This is the original and this is the regression value output. Now, after these three values, I can go and apply in SVM. Then I can see how it is predicted. Here itself, we can see thousands of informations can be made out. At the same time, see some other x value and x2 value. You have y4 value. Of course, SCM will work out for this data, whereas linear regression may not work for this. And that is also an innovative gap where you can identify. For example, if I take some finance and if I take some other thing about the parameter, instead of finance, I can take daily wages, I can see how it is matching. Here is only a research is happening. And not that taking the code app, having the graph and saying that in Colab I have done it, I have got the graph for my data. No, it's not like that. You have to understand what happens in the background. Okay, that is a very important thing. I think what I said was very clear to you, and I'll stop the recording here. And if you have any doubt, okay, you can ask the doubt, and you can put your questions in the chat, or you can unmute your mic, and then you can